So 7.6 is about solving right triangles, and what that means is it means find every missing part. So in this case, I still need to find the hypotenuse, and I still need to find the two angles. Well, anytime you want to find the third side of a right triangle, use our old friend, the Pythagorean theorem, and in this case, the sum of the squares of the legs. So 13 squared plus 9 squared equals c squared. So this is 169, that's 81. What does that work out to be? 250? Not positive on that. 13 squared plus 9 squared equals 250. Yeah, and I can see pretty quickly that that's 25 times 10. So if I take the square root of that, I get c equals 5 root 10. And I like to fill it in. What about these angles, though? So now I can use any choice, and for some reason I just kind of like tangent. And I say that the tangent of A is equal to 9 over 13. I actually know the ratio between these two sides. I know opposite to adjacent is 9 over 13. What I'm looking for is my angle. So in the past, I knew my angle and the calculator gave me the ratio. Now here's the ratio. I want the calculator to give me the angle. That's called an inverse function. So the way I write that is that I take the inverse tangent of the ratio will give me the angle. So on your calculator, you can see that's right up here, the inverse tangent. So I say the inverse tangent of 9 divided by 13 is 34.7. So my angle is 34.7. So if angle A is 34.7, B is just 90 minus 34.7, and that's 55.3. Okay. Here's my next one. Again, I have two sides, so how am I going to find this other side, D? I'm going to say that D squared plus 9 squared equals 17 squared. So D squared equals 17 squared minus 9 squared, and I have to use a calculator for that. Well, just to be fast. And I get 208. D squared equals 208. And when I take the square root of that, I get 14.4. I don't know if I can simplify that in radicals, but just to be quick, I'm going to call it 14.4. I don't know if I can leave it in radical form. Oh, the quiz says round decimals to the nearest tenth. Now, again, I don't know what angle, I don't know these angles. So let's start with D. And I have any of these, so if I use this, that's my opposite, and that would be my hypotenuse. So I would say that the sine of angle D is opposite 14.4 over hypotenuse 17. And again, I could have used tangent, or you can use cosine, just really depends on which two sides you choose to use. So, TOA, which two sides you're going to use, tells you which function you're going to use. And then again, I have the ratio, I want the angle, so I take the inverse of the ratio, and it will tell me what the angle is. So once again, how do I get that? I hit second sine, will give me inverse sine, and then I plug in my ratio, and I get 57.9. And so if this is, I didn't leave much room for myself, 57.9 degrees, this has to be 32.1 degrees. Yeah, your calculator knows the ratio, the trig ratios of all these angles. Let's do the third one. This one's a little different. Now I'm just given a side and an angle. So I'm looking right at this and I'm saying, hey, I want to find this side, J. So I would say the tangent, that's my opposite, and that's my adjacent. So I would say the tangent of 33 is equal to my opposite side over my adjacent side, 11. And then I can multiply both sides by 11, and I get j equals 11 times the tangent of 33. Obviously, it's nice to make a ratio where your unknown is in the numerator. It's just a lot simpler if I had done, well, even if I had used, if I had said, I would have, I don't know. Either way, try to set it up so your unknown's in the numerator. So 11 times the tangent of 33 tells me it's 7.1. So I'm going to come over here and put in 7.1, and then a squared plus b squared equals c squared. Oh, and if this is 33, this has to be, 57, right? Just by subtraction. And this is where if I had done that first, again, you can just do whatever you want to first. If I had tried to find j using cosine, that would have been, or tangent, that would have been opposite over adjacent, and then j would have been in the denominator. Not the best idea. And you can use Pythagorean theorem. I think it's the easiest, but if you wanted to use a trig function, you could say the cosine of 57 is equal to adjacent over hypotenuse. So yeah, see, look, that's not so good. So you gotta multiply both sides by h, then divide both sides by the cosine of 57. So h would be equal to 7.1 divided by the cosine of 57. And that's 13.0. Let's see if I had used Pythagorean theorem. 7.1 squared plus 11 squared equals h squared. So h is equal to the square root of this. And this case I got 13.1, but close enough. So Pythagorean theorem or trig functions. But to start off, I only had one side, so I had to use a trig function to figure out what the other side is. So that's how we solve right triangles, find all the missing parts. Right now,